Hello everyone. Today we will going to see some practice questions from the chapter Solution and it is part 4th. Let's start. Disclaimer slide which says the images used in our slide deck are for education purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. This is our index slides and we are going to see today's practice questions from question 31 to question number 40. Let's start with question number 31. Ethylene glycol is used as an antifreeze in cold climate. Mass of ethylene glycol which should be added to 4 kg of water to prevent it from freezing at -6 degrees Celsius will be. So we have to find out what will be the mass of ethylene alcohol needed to add to 4 kg of water to prevent it from freezing at the temperature of -6 degrees Celsius. Kf for water is given and molar mass of ethylene glycol is given. Options are 800 gram, 204 gram, 204.30 gram, 400 gram or 304.6 gram. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A, that is 800 gram. Let's see how. So del TF we know is the difference of freezing points of water. So freezing point of water minus freezing point of ethylene glycol solution. So we have del TF as difference in freezing points. So freezing point of H2 we know is 0 degrees Celsius and freezing point of ethylene glycol solution we have given in the question, that is -6. So 0 minus of 6 is 6 degrees Celsius because minus will become plus. And Kf we have given for water as 1.86 Kelvin kg per mole. W2 is mass of ethylene glycol in grams. W1 is mass of solvent, that is H2O in grams. These all are given in the question, right? M2 is molar mass of ethylene glycol, which is given as 62 gram per mole. And I is Hoff Factor, which is equals to 1 for ethylene glycol. Since ethylene glycol is a non-electrolyte, hence from the del TF formula, we have del TF equals to I into Kf into molality, right? So I into Kf into molality formula, which is W2 upon M2 into W1. And W1 is weight of solvent in kg. So we divided by 1000 and 1000 will come in the numerator in the multiply. Putting the values in this equation, we have del TF is 6, I is 1000, Kf is 1.86, W2 we have to find out. And upon M2 is 62 and W1 is 4000 as given. So W2 is coming out as 800 gram. Hence, option A is the correct answer. Okay, so let's move to question number 32. The molar mass of solute X in gram per mole if its 1% solution is isotonic with 5% solution of cane sugar is. Molar mass of cane sugar is given as 342 gram per mole. Options are 68.4, 34.2, 136.2 or 171.2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. So for isotonic solution, pi 1 equals to pi 2, where pi is equals to CRT and it is equals to osmotic pressure. So pi is osmotic pressure. So pi 1 is equals to pi 2. That means for solute X, the pi is equals to the pi of cane sugar, osmotic pressure of cane sugar. And pi is equals to CRT, and C is concentration, which is equals to number of moles divided by volume. So on equating the relations, and we have RT cancel out to RT because both are constant, and we have N1 by V1 equals to N2 by V2. Now for moles, we have given mass upon molar mass. On the right hand side, similarly given mass upon molar mass. Now W1 upon V1 into 100 equals to 1, as it is given in the percentage for isotonic solution. And W2 upon V2 into 100 is given as 5 in percentage for the cane sugar, right? So M1 we have to calculate, the molar mass of solute we have to calculate, and molar mass of solvent is 342. That is for cane sugar, which is given. So putting the values, equating the terms, we have 1 upon M1 equals to 5 upon 342. So M1 is coming out by interchanging the terms as 342 divided by 5, which is equals to 68.4, which is equals to the molar mass of a solute X. That is, molar mass of solute X is 68.4 gram per mole. Hence, option A is the correct answer. Okay, let's move to question number 33. We have the match the following and choose the correct option question. So we have given two columns, column first and column second in this question. Column first has 4 rows, and which says Raoult's law, elevation of boiling point, Henry's law, osmotic pressure. Column 2 has 4 rows, naming 1, 2, 3, 4. P equals to KHX, pi equals to CRT, P equals to x1 P1 naught plus x2 P2 naught, where x1 x2 are mole fractions, and 4 is del TB equals to KBM. So we have to match the following. We have to match the column 1 to the column 2. So options are, for A we have 3, for B we have 4, for C we have 1, for D we have 2. For A we have 2, for B we have 1, for C we have 4, for D we have 3. Or for A we have 4, for B 1, for C 2, for D 3. Or for A 1, for B 3, for C 2, and for D 4. So you have to match the column 1, that is A, B, C, D, to the column 2, that is 1, 2, 3, 4. You have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so let's see. So the correct answer is option A. So A will match with third, B will match with fourth, C will match with first, and D will match with second row. So A is for third. So Raoult's law is equals to P is equals to mole fraction of solute into vapor pressure of pure solute plus mole fraction of solvent into vapor pressure of pure solvent. B is a connection of 4, that is elevation of boiling point is given by del TB equals to KBM. This is also correct. C is for 1, so Henry's law is P equals to KHX, where KH is the Henry's constant. And D is for 2, so osmotic pressure pi equals to CRT. Hence, A option is the correct option. Every column first is correctly matching with the column second, right? Okay. So let's move to next question. Question number 34. When 20 gram of naphthoic acid, which is C11H8O2, is dissolved in 50 gram of benzene, the Kf for the benzene is given, and a freezing point depression of 2 Kelvin is observed. We have given a depression of freezing point which is of 2 Kelvin. the Van't-Hoff factor I is. So we have to calculate what will be the Van't-Hoff factor for this process. So naphthoic acid weight is given as 20 gram and benzene weight is given as 50 gram. Its Kf is given as 1.72 Kelvin kg per mole, and we have to find out the depression. The depression in freezing point is given as 2 Kelvin, and the Van't-Hoff factor we have to calculate, that is I. Options are 0.5, 1, 2, 3. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer is option A, that is 0.5. So let's see how. Actual molecular weight of naphthoic acid, C11H8O2, is equals to 172 gram. And the molecular mass, if we calculate by using the depression in freezing point formula, we have 1000 multiplied by Kf multiplied by the weight of solute upon weight of solvent into del Tf, right? As we know that del Tf equals to Kf into M. So molarity formula we have equated here. We have write the molarity formula in terms of weight of solute and weight of solvent in kg, and Kf we have written, and the molecular mass of the solute we have replace it with del Tf because it will come on the left hand side. That is del F is equals to Kf into M, right? So del F will come in denominator and molecular mass will come in the numerator in the left hand side. So on putting the given values in this equation, we have 1000 multiplied by 1.72 into 20 divided by 50 into 2, right? So it is coming out as 344. So molecular mass calculated is coming out as 344. And this is the formula of Van't-Hoff factor, that Van't-Hoff factor I equals to actual molecular weight, which we know, and upon calculated molecular weight, which we have calculated from any formula, right, using any formula. So on putting these two values in the fraction, so 172 actual molecular weight divided by calculated molecular weight, which is 344, and this fraction is coming out as 0.5, which is equals to the Van't-Hoff factor. So I equals to 0.5. Hence, option A is the correct answer. Okay, so let's move to next question, question number 35. We have three aqueous solution of NaCl labeled as A, B, and C with concentrations 0.1 molar, 0.01 molar, and 0.001 molar, respectively. So the value of Van't-Hoff factor for these solutions will be in the order of. So we have to calculate the Van't-Hoff factor for these three solutions A, B, and C, and we have to tell their order also. Options are the Van't-Hoff factor, that is I, for C is greater than for B is greater than for A. Van't-Hoff factor for A is greater than for B is greater than for C. Van't-Hoff factor for A, B, and C are equal. Van't-Hoff factor is greater than Van't-Hoff factor for B is greater than Van't-Hoff factor for C and Van't-Hoff factor for A both. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer will be option B, which is the Van't-Hoff factor for A is the greatest, then the B, then the C will come. So greater the dilution, greater is the dissociation into ions, and hence greater is the Van't-Hoff factor, because Van't-Hoff factor depends upon the ions which is produced after dissociation of ionic compound, right? So the value of Van't-Hoff factor for these solutions will be in the order of, for A it is most, then for B, then for C. You can also see that NaCl will give you 2 ions after dissociation, and we have 3 aqueous solution of NaCl only. So I will be same. Sorry, I will be dissociation will be similar in A, B, and C, but the solution have different concentrations, right? 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3. So the most less or the most concentration is present in the A and least concentration is present in the C solution, right? Hence, the Vent-Off factor order will also be same for these three, like the most in A, then in B, and least in C, right? Because Vent-Off factor is variable here, we have to find out the Vent-Off factor for A, B, and C, and but we have given the concentrations. So by concentration, we can see that the greater the dilution, greater dissociation into ions, and the greater dilution will be for the greater concentration solution, right? Hence, the Vent-Off factor order is the most Vent-Off factor is for A, then B, and the least is for C solution, right? Hence, option B will be the correct answer. Okay, move to question number 36. Which one of the following aqueous solutions will exhibit highest boiling point? So we have to find out that from the given options, which one of aqueous solution exhibit the highest boiling point? Okay, so options are 0.01 molar Na2SO4, 0.01 molar KNO3, 0.015 molar urea, 0.015 molar glucose. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A, that is 0.01 molar Na2SO4. So the boiling point of the solution is directly proportional to Vent-Hoff factor. Thus, for Na2SO4 given in option A, it is dissociated in this manner: 2 Na positive plus SO4 2 negative. So we can calculate that there are 3 moles of ions. So there are 3 ions dissociated, right? So I, that is Vent-Hoff factor for Na2SO4 will be 3. For KNO3, we have K plus plus NO3 minus dissociated ion, that is 2 ions. So I, Vent-Hoff factor for KNO3 is 2. Urea and glucose are poor electrolytes. Therefore, I for these two solutes are equal to 0. Hence, 0.01 molar Na2SO4 possesses highest boiling point because the Vent-Hoff factor is the highest. And the boiling point is directly related to the Vent-Hoff factor. So more the Vent-Hoff factor, more will be the boiling point. So highest boiling point will be in Na2SO4, which have highest Vent-Hoff factor, that is 3. Hence, option A will be the correct answer. Okay. Let's move to next question. Question number 37. A compound A undergoes tetramerization in a given organic solvent. The Vent-Hoff factor is, we have to calculate the Vent-Hoff factor, that is I here. Options are 4, 0.25, 0.125, 2. So you have 10 seconds to solve this question, and after that we will see what will be the answer. Okay, so we have answer as option B, that is 0.25. Let's see how it will be. So we have a compound A which is undergoing tetramerization. So 4A will become A4 at equilibrium. And initially 1 mole of A is present and the product moles are 0. But after dissociation, the moles of the reactant, that is A compound, is decreased by alpha, so 1 minus alpha, and the moles which is formed of product is alpha by 4 per atom, right? So I will be equal to the total moles is equals to 1 minus alpha plus alpha by 4. 1 minus alpha plus alpha by 4, which is 1 minus 3 alpha by 4. And alpha here is degree of dissociation, and it is equals to 1, or we can say that 100% dissociation is happening. So on putting alpha is equals to 1 in this equation, we have I equals to 1 minus 3 by 4, which is 0.25. Hence, option B will be the correct answer. Let's move to question number 38. The degree of dissociation alpha of a weak electrolyte AXBY is related to Vent Hoff factor I by the expression. Now, for a weak electrolyte AXBY, we have to determine the relationship between the degree of dissociation and the Vent Hoff factor. Options are alpha equals to I minus 1 divided by x plus y minus 1. Alpha equals to I minus 1 upon x plus y plus 1. Or alpha equals to x plus y minus 1 divided by I minus 1. Or alpha equals to x plus y plus 1 divided by I minus 1. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer is option A. So we have our weak electrolyte as AXBY, and on dissociating, it is giving X of A Y positive plus Y atoms of B X negative. Initially, XBY is 1 and the products are 0 and 0. But after dissociation, let's suppose they dissociate, AXBY dissociate by alpha. So 1 minus alpha and the product side is X alpha and Y alpha respectively. So the total moles is equals to Vent Hoff factor. That is Vent Hoff factor equals to moles of AXBY plus AY positive plus moles of BX negative after dissociation, right? So it is equals to 1 minus alpha plus X alpha plus Y alpha. On taking common alpha, we have 1 plus alpha into X plus Y minus 1. And on interchanging the terms, we have alpha equals to I minus 1 upon X plus Y minus 1. Hence, option A will be the correct answer. Okay, let's move on to question number 39. Which of the following aqueous solutions should have the highest boiling point? Options are 1 molar NaOH, 1 molar Na2SO4, 1 molar NH4NO3, or 1 molar KNO3. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. Boiling point of solution is directly proportional to Vent Hoff factor. We have seen this. And Na2SO4 possesses larger value of I than other given solutions because Na2SO4 gives more ions after dissociation. Hence, 1 mole Na2SO4 solution would have highest boiling point. So Na2SO4 gives highest ions after dissociation, and so I will be higher for Na2SO4. And as I is directly related to the boiling point of the solution, so higher I, that means higher boiling point. So 1 mole Na2SO4 have highest boiling point. Hence, option B is the correct answer. Okay, let's move to question number 40. In a 0.2 molar aqueous solution of a weak acid HX, the degree of ionization is 0.3. Taking Kf for water as 1.85 Kelvin kg per mole, the freezing point of the solution will be nearest to. So we have options here, which is minus 0.360 minus 0.36 degrees Celsius, minus 0.26 degrees Celsius, 0.48 degrees Celsius or minus 0.481 degrees Celsius. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. We have weak acid HX. It will dissociate in this manner, H plus plus X minus. Initially, we have 1 mole of HX and we have 0 and 0 mole of HX, H positive and X negative. But after dissociation, the 1 mole HX dissociate by degree of ionization 0.3. So 1 minus 0.3 and H plus and X minus will be 0.3 and 0.3 respectively. So total moles will be 1 minus 0.3 plus 0.3 plus 0.3. It will be equal to 1.3. And so I will be equal to 1.3 divided by 1, which is 1.3. And we know this relation that delta F, depression and freezing point, is equals to I, Van factor, into Kf into molality. On putting the values, I is, we have calculated 1.3 multiplied by Kf, which is given as 1.85, and molality, which is 0.2 molar solution, so 0.2, that is coming out as 0.418 Kelvin. So del Tf is Tf naught minus Tf. So Tf is 273, which is Tf naught, which is the freezing point of solution, which is 273 minus 0.418 Kelvin. So in Kelvin it is 273, in Celsius it is 0. So on subtracting this, we have 272.519 Kelvin, or in Celsius we have minus 0.418 degree Celsius. Hence, thus option D is the correct answer for this question. Okay, thank you.